Hello guys, hi again. So we just solved this problem using law of sines. But what if we go to the old engineering way, which is what I like, obviously. This is what we did, right? It's in the previous video that I recorded. Now let's see that I go and I say, no, I want to use force decomposition because I have everything here that allows me to use force decomposition. Once again, you read the problem. This is the angle. This is this, vertically upward, and has this magnitude, yada, yada, yada. So then what do we do? Find the angle and find the force. Okay, find the angle and find the force. Let's put this up because this is going to be my resultant force. And let's decompose these forces in components. What does that mean? This force in the x direction it has this component, and in the y direction has this component. This is equal to that, and this is equal to that, right? So basically, if I want to decompose this in x, this is going to be the x component of that force. And this is going to be the x component of this force. Now, if we start doing it in that way, I know for a fact that the resultant force don't have any resultant in the x direction. Why? Because it says that it's directed vertically upward. So there is no force in the x direction. So whatever I do summation of forces in the x direction, that has to be zero because there's no resultant force. No resultant in x. So let's do that. This component will be 500 sine of the angle, and this negative because goes to the left, no goes to the left, go opposite to the positive, but in this case it's left, plus this component which is f sine 30, and there's not anything else in the x direction, so equals 0, and I get one equation from here. Now what is happening in the y direction? Let's see what happens in the y direction. So I know that if I add these two in the y direction, it has to be equal to the resultant force in the y direction. And I know the value for the resultant force in the y direction, 750. So basically what we are going to do is calculate this component for this force will be 500 sine of the angle, cosine of the angle, positive because pound is pointing in the positive direction of the resultant force of the y direction. So 500 cosine of the angle plus f cosine 30, and that has to be equal to this value, which is 750. 750. And then I have a second equation here. And I know. You look at these equations and you start, going crazy. And why? I mean, this is so good. This is so nice. These equations are really nice to solve. So let's solve. For example, there are plenty of methods for solving this. But let's say that I want to use substitution. Why substitution? Because substitution is the method that you guys have implanted in your brains forever and ever and ever. I don't know why. Every time that I teach and I say, how do you solve a system of equations? Substitution. Sometimes it's not the best way to go, but let's do it in this case. So let's solve for f in the first one. If I solve for f in the first one, that's going to be equal to 500 sine of the angle divided by sine of 30. That means that f is going to be, this is zero point 0.5. If I divide it, zero point 0.5 is the same as multiplying by 2,000 sine of the angle. And then I'm going to get this and I'm going to plug it into that equation. And let's see what we get. So we get 500 cosine of the angle plus f, and f is this, 1000 sine of the angle multiplied by cosine 30. That has to be equal to 750, or 500 cosine of the angle plus sine 30 is 866.6, but just in case, I mean 0.866, just in case, 1000 times cosine of 30, 866.0, let's say 866. 866 sine of the angle equals 750. And now you freak out, because how do I solve that equation? Well, there are several methods. If you have this calculator, for example, and they allow you to use this calculator, you can just plot this. You pass this to the other side. This 750, you pass it to the other side, and you plot it like a function here. I'm not going to do it. You plot it like a function here, and you look for zero crossings, and that will be the value for the angle. But if you don't have that, and you have something like this, and this is a calculator, by the way, that they are going to allow you use when you take your licensure. You're not going to have a graphic calculator, your FE or your PE. It's going to be this type of calculators. That's why I'm using this type of calculators. You can use the good old trial and error method. What does that mean? That means exactly that. We're going to try and we're going to check and verify that what we're doing is correct or is not correct. So let's see, what does that mean? This is getting out of focus, so let me try to focus it again. Out of focus. Focus. Good. I'm going to guess a value for the angle, and I'm going to say, what if I say the value is 45 degrees? I should get 750, right? If this is 45 degrees. So let's put the equation here. 500 cosine 45. I'm going to put 45.0, which is the same, but I know I don't have to substitute anything later on. Plus 866 sine, I'm going to put the angle as 45.0. And I hit enter. And that's 965. And our target is 750. So this is not it. Now that means that the angle could be bigger or smaller than that one. So I'm going to try smaller. And I'm going to try now with 30 degrees. And you're going to think that this is going to take forever, but look how easy it is. You just go up, hit enter, and now you just change your angle and put 30 degrees. You put 30 here, and then you put 30 here. 30 degrees here. And then you get 866. 866. And I'm looking for 750, but you see, it's coming down. Let's try now 15 degrees. 15 degrees. Go up. And let's try 15 degrees here. 15, 15. And then we get 707. And look what happened. Our 750 was somewhere here in between these two. That means that our angle has to be also between these two, but really close to this one. It's way closer than this one. This is what is called zero crossing. So you have what? You have 866 here. You even could do interpolation now if you want to, which is what we are doing basically. And now we got here 707. And this is 750. This is what it was supposed to be, 750. And this is 866. And now we got 707. 750 is this one. So that means that for this value the angle was 30. For this value the angle was 15. That means that the angle has to be between 15 and 30, but closer to this side. That's where we are. So let's try 18. Up. Let's try 18. And this is really fast. Of course, it's faster when you have the other calculator, this calculator, for example, and you have the solver function. It solves it for you automatically. But I'm not saying that's cheating, but it's only cheating if you are not allowed to use it. Now, 18. For 18, we got 743. That means that is still between 30 and 18. Is a little bit above. Let's say 18.6 or 18.5. It's up to you. Now let's try 18.5 or 18.6. Why 18.6? Because I'm cheating. Because that's the value that we got here before. So I know that's the value. 18.6, 750. So the angle is 18.6 degrees, and that will give me the resultant force over there of that. Now, what is the other thing that we have to calculate? F. Well, F is just this. 1000 sine of 18.6 degrees, and F equals 1000 sine of 18.6 318.96, yes, which is same value that we got. Those are the same values that we got when we did it using the law of sine. Another method, another way. This is more engineering wise, the other one is more mathematical wise. Both of them are valid. So thank you for watching, guys. I hope that you are enjoying as much as I am enjoying creating this for you. See you next time.